Okay, gentlemen, just demonstrate for you how we would go about this doing manually. And I actually was asked why we weren't doing exercise 6B and 6C. Generally speaking, we wait till next year for you to learn how to use long division. Yes, that's right, long division. So why don't I first show you what, for instance, not many of you would know your 14 times table. So when we asked to divide how many times 14 goes into, say, 3,234, we would set up long division. Here we go. So you remember that? So the first thing you would go, right, I don't know my 14 times table, but I will do it doing this technique. So the first thing I say is 14 won't go into 3. 14 will go into 32. So that will estimate. I think we'll go twice. We put down the 2 there. And now we go 2 times 14. Notice how I multiply the 2 together to evaluate 28. You remember what we do next? That's right, we subtract 32, take away 24, 8 is 4. Then we bring down the next value. In this case, it's the 3. We have 43. Again, we estimate how many times 14 can go into 43. Well, more than twice. Can it go 3 times? And the answer is yes. We'll try 3. And we go 3 lots of 14. Again, multiply those, and we get 42. And subtract 1, and then bring down the last digit. And of course, 14 goes into 14 once. So 3,234 divided by 14 is 231 using long division. And that's the strategy that we use to do this. And that's why you must probably, why do we bother with long division? Because eventually one day you'll come along and you'll have to do this manually. Yes, you can use calculators like the previous video, so, what do we need to do? Well, we know that this is a cubic, and we know that once we factorize it, we'll end up with 3 brackets. Okay, we'll end up with 3 brackets. And here's the challenge. To do this manually, we're going to have to do some trial and error. We're going to have to try and guess one of these brackets. And so, like in exercise 6A, we're going to try either +1 or -1 as our possible values that could cause this expression to equal to 0. So let's try let x equal 1. So substituting 1, we have 1 cubed minus 7 lots of 1 squared plus 7 times 1 plus 15. Let's see if that's true. So 1 cubed is 1. Minus 7 times 1 is minus 7. Plus 7 plus 15. And we end up with clearly minus 6 plus 1. We end up with 16. And that clearly is not our solution. So we then try maybe negative x1. So let x equal to -1, I should say. So substituting, now remember it's negative is cubed. Minus 7, the -1 is squared, plus 7 lots of -1s, plus 15 equals 0. So, -1 cubed is -1. -1 squared is +1, but times it by -7, we get -7. 7 times -1 is -7, plus 15 equals 0. -1 minus 7 minus 7 is -15, plus 15 equals 0. So, yes, one of our solution is x equals -1. So, to find the factor, we take x equals -1. We want this to equal to 0, so we have to get rid of the -1 by adding 1. And what we do to one side, we have x plus 1 equals 0. And so there's one of our factors. So we now, if we go back to the top, we can already predict that one of the factors is x plus 1. And to get the other two, we know how to factorize quadratics. So why don't we use this technique called long division? All right, so let's recap. We've had to guess and test and trial a possible solution. Came up with x equals -1, which gives us the factor x plus 1. So now we want to know if, when we divide x plus 1 into the original function, which was x cubed, let's go through again, minus 7x squared plus 7x plus 15 equals. Okay, so what we're doing is we want to divide this factor to work out the remaining factor. And here's where we use long division. So we only focus on our x value. X, how many times do you reckon x can go into x cubed? And the answer is x squared. Remember what we did with the 14 and the 2? We went 2 times 14. Well, here we're going to go x squared times x is x cubed. And x squared times plus 1 is 1x squared. What do we do next is we subtract. So we end up x cubed, that cancels out, and minus 7x squared minus 1x squared is minus 8x squared. Now we do the same thing. This time we're dividing x into minus 8x squared. X into minus 8x squared gives us minus 8x. Again, we now take that, multiply that by the x, will give us minus 8x squared, and the minus 8x times plus 1 is minus 8x. Oh, that's right, I forgot to bring down the 7x. Yes. So as you can see, a lot of what we learned in year 7. Again, we subtract. Again, here we cancel out nicely, and 7x, be careful, minus 8x is plus 8x, which makes that positive 15x. I won't make a mistake this time. I'll bring down the plus 15, and x divided into 15x gives us positive 15. Again, we multiply that. 15 by x is 15x, and 15 by 1 is 15. So we end up with 15x plus 15, subtract, and we have the end. So we can now say that the x cubed minus 7x squared plus 7x plus 15 can be also written as x plus 1 brackets x squared minus 8x plus 15. And as Mr. Farragut showed you, we should be able to factorize this. So the quadratic x squared minus 8x plus 15. And remember, we need the factors of 15, which is 5 and 3, 15 and 1. That's all we have. And as you can see, there's the combo, 5 and 3. We need them both to be negative, okay? Both to be negative. And as a result, what we shall have is x minus 5 and x minus 3. So, therefore, the factorized form of that, it becomes the x plus 1, the x minus 5, and the x minus 3 equals 0. Remember, the original was x cubed minus 7x squared plus 7x plus 15, 0. Remember, we did the first step, and we got the second step using the quadratics. And finally, therefore, x equals negative 1, positive 15, 5, sorry, positive 3. Let's just confirm that with our calculator. say for this year, we don't expect you to use your calculator. So let's get the calculator out. Go Control New. I'll just do that. So we go menu 3, 1 to solve, menu 3, 1, solve. That was x cubed raised to the power of 3 minus 7x. Oops, didn't work. Minus 7x squared plus 7x plus 15. Oh, gee, I'm not catching it. Try again. Plus 7x plus 15. Remember the null factor law. We want to find where it cuts the x-axis. We're solving for x. And there you are, the 3 and the 5. Or if I was to do the factorized form, menu 3, 2. Just delete a couple of extra stuff there. And that's what we found. Remember, we guessed one of them and used the quadratics to solve for the other. Anyway, if you're willing to have a go at it, try long division. Have a good day.